Betelgeuse. A giant nearing the end. One of the most captivating and mysterious celestial events of our time revolves around a single, massive, dying star, Betelgeuse. Often humorously mispronounced as Betelgeuse, Betelgeuse is a red supergiant that resides in the shoulder of the Orion constellation, one of the most recognizable patterns in the night sky. Easily visible without the aid of a telescope, this reddish point of light has fascinated stargazers for centuries. But what truly captures the imagination of scientists today is not just its glow, but what it might be preparing to do next. In late 2019, observers around the globe noticed something strange. Betelgeuse began to dim significantly and quickly. Over just a few months, its brightness dropped so much that it was no longer the second brightest star in Orion. It became clear to both professional astronomers and amateur skywatchers that this was no ordinary flicker. The question arose: was this the beginning of a supernova? Betelgeuse, or Alpha Orionis, is no ordinary star. It's a red supergiant, one of the largest types of stars in the known universe. Though it's around 640 light-years away, its sheer size, hundreds of times the diameter of our Sun, makes it one of the most prominent stars in our sky. Its name, derived from Arabic, means, the armpit of the giant, referencing its position in Orion's outline. Despite being less luminous than Rigel, the blue-white star marking Orion's leg, Betelgeuse often steals the spotlight. Why? Because of its distinctive crimson hue, massive scale, and dramatic behavior. Betelgeuse loses nearly one solar mass every 10,000 years, shedding vast amounts of material into surrounding space and forming an immense cloud of gas and dust that stretches out as far as 30 astronomical units, nearly the distance between the Sun and Neptune. Inside, this colossal star is burning through its nuclear fuel at a rapid pace. It has already fused its hydrogen and helium into heavier elements and is now fusing carbon and neon. Eventually, this process will halt when it reaches iron, an element that doesn't release energy through fusion. When that moment comes, the star's core will collapse, and in a fraction of a second, Betelgeuse will die in a supernova explosion, one of the most violent events in the universe. But was the 2019 dimming a sign of that imminent explosion? Many scientists initially thought so. The fading was dramatic. By February 2020, the star had lost more than two-thirds of its visible brightness. But thanks to observations from powerful instruments, including the Hubble Space Telescope, we learned that the drop in brightness wasn't due to the core collapse. Instead, Betelgeuse had ejected a huge cloud of gas and dust that passed in front of the star, temporarily blocking its light from our point of view. This outburst was 400 billion times more powerful than a typical coronal mass ejection from our Sun. Yet, in the infrared spectrum, Betelgeuse's brightness remained unchanged, confirming that the dimming was a surface event, not an internal collapse. By late February 2020, Betelgeuse began to brighten again, and the excitement surrounding a potential supernova calmed, but didn't vanish. Because the truth is, Betelgeuse is still dying. Red supergiants like Betelgeuse are short-lived on cosmic timescales. While our Sun will live for about 10 billion years, Betelgeuse, with its immense mass and energy output, is expected to last just 8 to 10 million years. It's already near the end of that lifespan. Adding to the intrigue is the fact that Betelgeuse is a pulsating variable star. It goes through regular cycles of expansion and contraction, which cause changes in brightness. These cycles are complex and overlapping, one lasting roughly 400 days, the other stretching over about 6 years. These expansions and contractions are caused by the convective currents in its outer layers, somewhat like a slow, cosmic heartbeat. Measuring Betelgeuse is no easy task. Its visible diameter can vary by as much as 35%, depending on the wavelengths of light used to observe it. Moreover, the layers of gas and dust surrounding it can either obscure or enhance its glow, depending on their configuration and our viewing angle. Even so, astronomers have captured astonishing images of this star. The Very Large Telescope, VLT, in Chile has shown detailed images of massive plumes of gas erupting from its surface, signs of tremendous instability in its outer atmosphere. These plumes, extending dozens of astronomical units into space, are a direct result of the star's shedding of mass in its final years. With each mass ejection, we get closer to understanding what happens in the final Betelgeuse, the final countdown to a cosmic spectacle. As Betelgeuse continues its unpredictable behavior, astronomers remain on high alert, watching, measuring, and preparing for what could be one of the most extraordinary astronomical events in human history. When Betelgeuse does finally go supernova, the event will be nothing short of astonishing. The explosion will unleash a staggering amount of energy, releasing more power in just a few seconds than our Sun will generate over its entire 10 billion-year lifespan. From Earth, the supernova will be bright enough to outshine the full moon. It will be visible in the daytime sky for weeks, perhaps even months. Imagine looking up on a sunny afternoon and seeing a second star glowing overhead. But what about Earth? Will this explosion pose a danger? Fortunately, no. Even though Betelgeuse is relatively close on a cosmic scale, about 640 light-years away, it's still far enough that the intense radiation and shockwaves from the supernova won't reach us in harmful levels. There's no threat to our atmosphere, life, or the planet's ecosystems. Instead, the explosion will offer a rare observational opportunity, the kind that scientists have dreamed of for generations. Instruments across the planet and in space are ready. Telescopes such as the James Webb Space Telescope, Hubble, ALMA, and the Very Large Telescope will all point toward Orion when the moment comes. They'll capture data in every wavelength of light, from gamma rays to radio waves. But the light show isn't all we're waiting for. When Betelgeuse explodes, it will also release a flood of neutrinos, tiny, nearly massless particles that move at nearly the speed of light. These particles will reach Earth before the light from the explosion does, giving astronomers a few hours of early warning. Detectors like IceCube in Antarctica are constantly monitoring for such neutrino bursts. In addition, a Betelgeuse supernova could generate gravitational waves, ripples in the very fabric of spacetime. These subtle distortions, predicted by Einstein's theory of general relativity, are now observable thanks to advanced detectors like LIGO and Virgo. Catching gravitational waves from a supernova would be a groundbreaking achievement, offering insight into the physics of stellar collapse and the structure of matter under extreme pressure. But beyond the science, there's something poetic about Betelgeuse. Stars like it are the factories of the universe. When they explode, they scatter essential elements, carbon, oxygen, iron, gold, into space. These materials are the raw ingredients of planets, life, and future stars. Without supernovae, there would be no Earth. No you. No me. Betelgeuse is more than just a point of light in the sky. It is a cosmic timekeeper, ticking steadily toward an inevitable end. And yet, its story is far from tragic. Its death will mark a beginning, providing insight, inspiration, and perhaps even a sense of unity as the entire world turns its eyes skyward. So, when will it happen? The honest answer: we don't know. It could happen tomorrow, or it might not happen for 100,000 years. But the more we study Betelgeuse, the more we observe its convective patterns, its mass ejections, its rhythmic dimming and brightening, the closer we get to understanding how the most massive stars live and die. Until that moment comes, Betelgeuse remains a mystery wrapped in light, a magnificent red beacon on Orion's shoulder, drawing the curiosity of scientists, storytellers, and skywatchers alike. It may flicker. It may pulse. But one day, it will erupt. And when it does,